So first off, I want to say thank you guys so much for coming today. I know it's getting towards the end of the day, so thanks for coming to the talk and having patience. My name is Eitan Margar-Epstein, and I'm an engineering manager on Daydream. And today I want to talk to you a bit about virtual reality at Google and what we're planning on doing, and sort of give you a glimpse of the future. Unfortunately, the product that I'm going to talk about today isn't yet available in China, but it's something that we want to make available, and I want you guys to have a preview of what's going on. So to get started, this is Daydream. I guess maybe by show of hands, how many of you have seen Daydream before? Okay, pretty good. So Daydream is Google's first mobile VR offering. It consists of a headset paired with Google Pixel phones and a controller, but it's going to be coming to a lot more phones as well. So there's a Daydream compatible spec that phones can meet, and they can come out. And compared to a lot of offerings in the space, it's relatively cheap. So when you think about buying a VR headset, it can be very, very expensive right now. And Google really wants to bring VR to the masses. So we're offering Daydream View in the US right now as an add-on to the Pixel phone for $79. And it launched on November 10th. So it's a relatively new product in the space, but we're very excited to see how it takes on. The rest of the talk is going to be about the platform, about some of the developer tools, and about designing for VR, which I think is a unique challenge. And to start with, we've already got a lot of progress here. There are already people who have built applications and studios and close partners that have released their applications on the Daydream platform. So with launch, we actually have a number of apps out there. And I encourage you to go by our booth and check some of them out. All right, so let's start with the platform. I think Daydream is unique in that normally when we talk about a platform, we talk about some piece of hardware. We talk about a new phone, we talk about a new watch, we talk about a computer. But for Daydream, the platform is really you, right? The entire point of virtual reality is to trick your body and your sensors into believing that you're somewhere that you're not. And when we do this, one of the things that's really, really important is trying to trick all of your sensors at once. So when you think about the actual world, the real world, when I move my head around, my inner ear, my vestibular system, actually notices that I'm moving. There's fluid in my ear that notices that I'm moving my head. And at the same time, my eyes are tracking out in space, and my eyes also notice that I'm moving my head. And the latency between them, the delay, is 0 milliseconds, right? As soon as I move my head, my inner ear notices, and my eyes notice as well. But when you think about this process for a cell phone, it's not quite the same. So here, my inner ear notices right away, again, that I'm moving my head. But now, before I can update my eyes, before I can change what's on the display in front of me, a bunch of stuff has to happen. So first, there are inertial sensors in the phone, accelerometers and a gyroscope that have to notice that the motion has happened. Then I need to do some processing on the CPU to decide what I'm going to draw. Then I need to actually draw it on the GPU, and then that needs to go to my eyes. And that all adds up. This is sort of what you would see on a traditional cell phone processing pipeline. And here, it's 85 milliseconds, so that's up. But what we know is that we need to get this down to below 20 milliseconds. So 20 milliseconds is kind of that magic number, that time where your inner ear and your eyes, even though there's a delay, you don't actually notice it. It still feels good, and you don't get sick. And screwing this up is really bad, right? Like, we make people sick. Bad VR makes people sick. If you're sick in VR, you're sick in real life. So we've done a lot of work to get our motion to photon latency, the time from when you move your head to when light enters your eyes, below this magic 20 millisecond number. Another challenge that we have in designing for Daydream is that we have a mobile device. So on a mobile device, you're dealing with 6 or 7 watts of power draw. It's not a very powerful desktop machine. We're competing, I guess, with these power plants that draw over 600 watts. And so we have to play a lot of tricks and be very conscious in the way that we develop applications to make sure that we're hitting these power requirements. And there's a lot that we've done there to help developers out. So here are some of the things that we've worked really, really hard on to both reduce the power requirements for Daydream, as well as to reduce the motion to photon latency. So the first one is that Daydream compatible phones have low persistence displays. They have OLED displays that refresh very, very quickly. They also have very high performance mobile CPUs and GPUs. So the Pixel phone is using Qualcomm's top-of-the-line 820 processor, so we can do as much processing as possible in a mobile form factor. And then the second, or the third piece, is low latency sensing. So we want to know as quickly as possible when you've actually turned your head to the left or to the right or up or down. And these are the components that make a phone Daydream ready. So we want to make sure that people don't get sick when they use our products. And so we have this specification where you as a manufacturer need to meet these requirements in order to build a Daydream ready phone. The other thing that we've done is we've worked really hard in Android N to build into the platform itself mechanisms for making sure that Android is a really, really high quality platform for virtual reality. So the first piece of that is sustained performance. So normally, when you've got your phone CPU, it spikes. It can go really high and really high performance, and then it goes back low. And that's the normal way that applications work on phones. They sort of need a lot of performance for a very short amount of time. But with VR, we're kind of changing that paradigm. And now you need to be able to run with a good amount of performance for a long period of time. And so we've introduced sustained performance mode, which throttles the clock rate down to give you overall more performance than you would have and keep the device from overheating. If you ran it at full throttle all the time, the device would overheat very, very quickly. And so we built in mechanisms to the operating system itself to ensure that you can run VR experiences for a long time. The second piece that we built into Android N is very, very good head tracking. So again, very quickly going from that sensor to being able to give your application the pose of a person's head as it moves. And then the third piece is that we've actually worked hard with the Android team to build a system UI that works in VR. So when you think about putting on a VR headset with your phone, normal Android doesn't make sense anymore. It's designed for 2D. But we've started to bring pieces of Android into 3D so that you can have a very good and solid experience in VR in Android. And we built that into Android N itself. This took a lot of hard work from the Android team and our team, and we're excited to continue this in future Android releases as well. All right, so here again is the view. You take your phone to use it, undo the latch, put the phone in the view. There's an NFC reader in the headset itself that recognizes when the phone is in, and then you're in VR. It also comes with a controller. And you can see that this controller has 3 buttons on it. So it's got a clickable touchpad. So that's actually touch sensitive, so you can swipe and gesture on it. You can also press down. And then it's got these 2 other buttons. So an app button that can be used for application menus, and then a home button that can get you back to Daydream Home, which I'll talk about in a little bit. The controller is also really special in that it provides a really natural interface for VR, so it can track its orientation as well. So inside of the controller itself are inertial sensors too. So there's a gyroscope and accelerometers inside of the controller, and this helps you understand where it is in space. So you can use it as a laser pointer, and we've also done some work to hook it up to an arm model to kind of fake 6 degrees of freedom motion in your applications. All right, so at that point, you've got your controller, you put it on, and you're inside Daydream, and slide changes, this is what you see. So we've worked really hard, again, to integrate Daydream into Android itself. And we've got a deep integration also with Google Play, so our store. And you can browse content in VR. You don't have to leave VR to browse content. You can decide which apps you want to buy. You can see reviews from people. And this all happens without having to leave VR. And it's all integrated to sort of the same backend that we use normally at Google, which is convenient for people. And then the other thing that we built into it is in-app purchases. So we understand that for a lot of developers, it's important, not to just follow a premium model where you might get people to buy your application up front, but also to build in-app purchases where you can do, freemium models and sort of take advantage of the traditional monetization techniques available to you on mobile. All right, so that, in a nutshell, is the platform. That's what we're delivering. Now I want to talk a little bit about developer tools. All right, so for Daydream, you're inherently developing in 3D. It's an environment where you have to create 3D content, author it, and put it out into the world. And so we offer a couple of different ways to develop for the product. So the first one is Android, which is what you're all familiar with. It's just stock Android development. And this makes a lot of sense if you want to do your own 3D rendering. But we've also worked really, really hard to provide integrations with popular game engines. So the first one is Unreal Engine. We've worked with Epic on that. And the next one is Unity Engine. And these engines allow you to get very quickly started with 3D content and sort of bring it into this virtual reality world. So I'm going to walk through each of these just really quick and give you kind of like the 30-second to a minute getting started guide for all of these different ways you can develop for VR. So the first one is the Android NDK. You'll want version 1.0.2 or higher of Google's Android SDK, and you can get it on GitHub right there. And this is kind of how it looks. So here, you can see we've got our normal activity in Java, and we're going to create a GL surface view the same way that we would normally render OpenGL content in Android. And above it, you'll see there's something special where we create this GVR layout. So that's going to give us access in native code, actually, to the Google VR context. And that's what we'll use to interact with the Daydream system and get the information we need for virtual reality. Then the rest of it is pretty standard. So on creation of your surface, you're actually going to call through the JNI to native code to hook it up to the rendering engine of your choice. And then on draw frame, you're also going to call through the JNI to native code to do the rendering work. And then at the bottom there are just some settings. So one is setting scanline racing to be enabled. So one of the things that we can do to reduce the latency of VR is if you think about how you write pixels across the screen, it actually doesn't happen all at once. There's kind of a line that moves across the screen. And so we actually write just after that line. So we're always following it and writing directly into that frame buffer. And then we're just going to say, okay, we're going to set this surface view as the one we want to render. So then inside of your native code, you'll remember there were those two methods that we called. So here you just initialize the GVR API, Google VR API, and then you can see that it will give you a recommended render target size. So what this is doing is based on the configuration of your viewer, it's going to tell you what size you need to render to. And this is important because for VR, when you look through the lenses, you actually need to see a distorted image. The lenses are really great in that they sort of allow you to see very far away when a screen is very close to you. But you have to apply distortion to your image in order to make it seem like the world looks bright distortion-wise when you look through the lenses. So then you just pass your render target into your frame buffer, and then you're off and running. And then inside of draw frame, you're going to get the head pose, again, from the GBR API, so you don't have to do any work to get the head pose. You just get it for free. You know exactly where the person is looking. You draw the left and right eyes normally. You don't have to apply any distortion. And then you'll see at the bottom, you actually call this distort off-screen frame buffer to screen. So that, again, is using the characteristics of the lens based on the render target size as well to do the proper distortion, and just takes care of things for you, and it'll draw the image properly on the screen. There are a couple of additional settings that you need to set in your manifest. One is just to say, I want to use VR mode, and the other one is to use VR high performance mode. So before I talked about sustained performance mode in Android, this way of throttling the CPU to be able to give longer running application times. And there are actually two different modes. So one is high performance, which is good for games and applications where you're only going to be running for 30 to 45 minutes on average. And then the other one is just sustained performance, and that will actually run for an hour plus. So that's really, really good for multimedia content and things like that. And then there's one additional thing that you can do in your manifest, which is just to say, I am a VR app, and I am a Daydream app, and that'll allow you to show up in sort of the Daydream home application. So that's native, which is relatively complicated, I guess, compared to our other integrations. So now I'll talk about how you get started with Unreal Engine, and this is much quicker. If you want, you can download Unreal Engine 4.13 or later, have Daydream built in, and you can go to the link right there to find them. So in Unreal Engine, you just select that you want to use a plugin, and then inside of the plugins menu, you'll see that there are a number of offerings, and you'll want to enable Google VR, and you'll want to, I guess, deselect all of our competitors that are also offered in Unreal. So you do that. And then you're going to set on your target hardware, you just want to make sure that you select mobile tablets and scalable 2D and 3D. And then there's one setting that is a little bit non-intuitive, so you're going to disable the default touch interface because Unreal Engine has a joystick by default. And then you're going to disable mobile HDR because it interferes with the stereo distortion process that I described in native before. And then you just target Android level 24, so Android N, and you're off. That's it. Now you can use Unreal Engine like you normally would. You place your camera, and you get VR rendering for free. Unity is equally simple. So for Unity, there's a technical preview that's out, and actually new versions of Unity will have this built in, but you can find the technical preview at this link. And for Unity, oops, I think I exited that. So for Unity 5.6 or greater, it'll have this built in. So there you go to your player settings menu on the upper right, and you'll just select virtual reality supported. There's just a checkbox, and then you select Daydream from the dropdown. And then there are some additional parameters you can set on your depth buffer format. You'll want to, again, target the Android N APIs. And you're off. That's it. For Unity, it's very, very simple. You can build your application as you normally would, and then you're off and running. So the next piece that I want to talk about a little bit is designing for Daydream, or for VR in general. I think that VR is a really challenging and interesting space, and we actually have more of an obligation, I think, to our users than we do in other applications. I think in VR, it's very, very easy to elicit an emotional response from the people who are using your experience. It's very easy to frighten people, and it's also easy to make people sick. So there are some things to consider when designing for Daydream that I'll talk about. The first one is, I think you should really forget that you're using a phone. Normally, when people use phones, we think about them out, on the go, at a coffee shop, just very, very quickly checking email or texting friends or maybe playing a game on the bus, something like that. But we actually have some studies, some early studies coming in about how people use VR. And I think that what you'll see here is that they're not actually using their mobile VR devices out at a coffee shop. They're using them in their living room or their bedroom. They're using them at home. And then the other thing to notice here is that they're actually using them for a prolonged period of time. So you're not operating with this, couple-minute session. Now you're talking about people using them for 30 to 45 minutes on average for playing games or interactive experiences. And you're talking about people using them for an hour plus when they're viewing media content. So you actually have your users in VR for a long, long time. And I think you should almost think about VR as sort of reading a book or telling a story. You have an opportunity to engage with your users for a long period of time. And that opens up different possibilities for you and sort of changes how you would design. It's not quite mobile design. It's something in between. The second thing that I think is really useful is that you should use your hands. I think one of the things that makes VR so compelling, at least with Daydream, is this controller. It really provides a feeling of presence to be able to interact with your environment and point to different things. And again, you have a clickable touchpad available to you, and you also have an app button and a home button. You can actually make use of the controller and track how it's moving through space and change the interaction. And there are some very, very clever things you can do with the controller. So we've provided some examples for you that you can download off of our developer site. But we use the controller to do things like scroll through paginated lists of image tiles if you want to do video feedback. Or we've done a number of experiments about how we can actually push the boundaries of the controller. So in the upper left, you'll see that we're using it to play mini golf, just as a putter. In the upper right, we're using it to navigate around the solar system. In the lower left, we're, flipping pancakes on the beach. And in the lower right, we were hitting baseballs with a bat. So even though the controller has relatively simple sensing in it, I think you can use it to create really powerful and immersive applications. And it's something that is a major differentiator, I think, for Daydream over other VR platforms, certainly in the mobile space that are available today. The other thing I want to say about Daydream is that you should really keep your experiences comfortable. I was talking earlier about how we have great responsibility when designing for VR, and Google's gone to an incredible amount of effort to make sure that the viewer itself and the controller itself feels comfortable. So we realize that this is in some ways a mix between a phone and apparel in a way, and that it's something that you're going to be wearing on your face. And so we've taken great care to design Daydream with very soft materials that feel good on your face, that fit over glasses as well, because we know a lot of people wear glasses. And we've designed the controller to fit in your hands, to be light, and to be comfortable in your hand. Another thing is that I think a lot of us, when we work, sit in chairs that look kind of like this. And so it's very tempting to design VR experiences that are full 360, because swivel chairs are great for full 360. But the reality of it is that most of our users are sitting in chairs that look like this. They don't actually rotate around, and many people use VR in bed and in other comfortable settings. And so when you're thinking about designing VR experiences, then you kind of want to think about a quarter of a sphere in front of you. Like, what are the areas that are comfortable for someone to sort of rotate around in a seat and see, rather than forcing them to turn around awkwardly as if they're on a swivel chair when they're not. And then there's motion. So this again gets into this disconnect between your inner ear and your eyes. If you go into a VR experience and you just start moving someone very, very quickly, it's a great way to make them sort of throw up. And so there are a few different classes of motion that we actually are informing users of when an app is submitted to the store. So the first one is no motion, where you're just sitting in a chair and you're maybe looking at a screen in front of you. You're not moving very quickly. The second one is moderate motion. Maybe you're moving at a walking speed, And this tends to be okay. People can kind of tolerate this. But the third one is extreme motion, where you're flying, you're moving very, very quickly through space. And I think that especially when you get into the third piece, it's really important to apply techniques like tunneling, so teleporting from one place to another, or sort of collapsing the field of view, so you just have one point in front of you that's moving fast and the rest of the scene is stable. And we're working to release tools that will help you as developers build experiences that are comfortable even when you're moving into these more and more intense motion realms. And then another sort of last piece of designing for VR is that you can make people really afraid. I don't know how many of you have been in VR and tried to step off the edge of the cliff, but many people have a fear of heights and they just cannot do it. They cannot step forward. So that's one. You can also feel very, very awkward when a virtual object intersects your physical body. You look down and you're very confused. It just feels wrong. You can make people feel very claustrophobic. You can make people feel agoraphobic, where there's a huge space in front of you and it's disconcerting. Being stabbed in VR is not fun. You actually feel a response even though nothing happens to you actually. And being crushed in VR is also a very, very scary experience. So these are things that might be fun to just try and experience to see what your reaction is, but it's not something that you want to do to your ultimate user. And then the last piece that I think everyone forgets with VR is just how powerful audio is. So when you think about rendering a tree, you can think about rendering this very, very high quality tree. You want to get the idea that the tree is actually there, that the wind is blowing through the tree, that birds are chirping. But another way to render this tree is to use sort of a low poly version of the tree. Oh, sorry. And instead, use audio to give a feeling that you're there. And we have a spatial audio SDK that I encourage all of you to go look at and try out, that really allows you to feel like you're there. You can listen to the wind and hear the birds chirp and give the illusion that this tree is real just through sound. And I think if you think about sound as like bang for your buck in terms of watts per level of immersion, in terms of power per level of immersion, audio is really, really good because it doesn't take a lot of power to generate, but it does give you the feeling of being there. Our audio SDK also allows you to change the sound based on the environment that you're in. So if you think about walking through a forest and what that sounds like, relative to walking through a spaceship and what that sounds like, it's very different. It depends on the material properties of the space. And so our SDK will actually model the material properties of whatever space you've designed in Unity or Unreal and change the sound that is played based on the properties of the space that you're in. We're still learning a lot. All of this came from a lot of experimentation that we did. We have a group called Daydream Labs that essentially just tinkers with VR. We try new things. We try to see if they'll work. We see what breaks and what doesn't. And we produce those learnings and try and share them with you. And we actually have a number of experiments that we've released as our controller playground. So we worked a lot with the Daydream controller to figure out what felt good and what didn't. And we have, I think, 16 different demos that are available to you. So if you want to get started, if you want to play with what it feels like to use the Daydream controller, shoot magic wands and swing bats and flip pancakes, you can do that all in VR. All right, and so the last thing that I'll show, I guess, before I end, is some work that's been done by our partners. I think it's really interesting to see what other people have produced for a given product and platform. It's really early days here, but you can check out some of the stuff that people are building already. So I'll play this video. that, in a nutshell, is Daydream. Normally I would point to the .com link, but actually we have also launched our Chinese version of our developer documentation. So if you go to developers.google.cn/VR, you can find everything that I've been talking about here and more. Also, you should make sure to check out our booth if you haven't already. So we're demoing a few things at the booth. The first one is Daydream, so you can actually try some of the applications that I showed here. The second one is Google's built VR products for the HTC Vive as well. So you can try out Google Earth, and you can also try out Tilt Brush, so a painting application. They come really highly recommended. And then right after this talk, my colleague Wim Houston will be talking about Project Tango, which is Google's augmented reality offering and augmented reality phones. And those are actually coming to China very soon. So I'd encourage you to listen to that as well. I think I do have some time for questions. I wasn't going to take questions, but I'll take a couple if the audience is interested. So, yeah.
主要想问一下，就是 Daydream 平台它是针对于移动方面的，还是说对于图形更有针对于移动方面比较优势，还是说针对高质量、高品质的图形上面优势？也就是说，我 Daydream 上面的一些 App、一些游戏，我是让用户感觉到这个游戏的动性比较好，还是说让这个用户感觉到它的画面更精美还是它的品质更好？动性就是指它的操作比较简单，就是说随时就可以在哪还有一些质量的完全不同的地方。对于这个 Daydream 的话，它的重点是在于操作性上，还是在于图像的质量上？
So I guess the question was, for Daydream, what's the most important? Is it the UI and user interaction, or is it the graphic quality? And it's a good question. I think there's no easy answer to it. I think it's actually both. I think first and foremost, reducing that latency, the motion to photon latency I talked about between when you move your head and when your eyes actually see the screen, is the most important in that it keeps you from getting sick. But then the UI design after that is also very, very important piece. Okay, let's go maybe there in the specs. Yeah.
I have tried Daydream today, and then I find two problems. The first one is it's not very friendly with who wear glasses. The second problem is when I using it, I can't see things around me, so I may look on something. I'm interested to know whether you and your team had any further plan to deal with this.
Yeah, so the two questions were, one, that Daydream is still uncomfortable with glasses, and then two, that you have no context for what's around you, and so you can bump into things, and it's sort of dangerous in that way. So for the first one, one thing that I found, we did work hard to try to make it good with glasses, but you have to tighten it really tight. It's really important to get the strap tight. I think that we are going to be doing other iterations. You know, we're going to be learning from the design. And so in future iterations of the viewer, I think you'll see us work even harder for glasses. But one tip is to really tighten it a lot for when you have glasses on. For the second piece, which is, you know, can you be aware of your environment? So for right now, you know, we suggest that people use Daydream in sort of a safe space without moving around a lot. I think that you will see over time, like there are systems, if you look at what's going on in sort of the desktop VR space, you know, there's at least Guardian from HTC to keep you from hitting things, but I think it's a problem that is going to need research and need the community to work on it. Like I think a lot of people are thinking about it and realizing like, okay, to use VR in your home, you know, you need need to understand where things are. So I expect it's something that we and also others in the space will be working on over the next couple of years. Thank you. Yeah.
我想知道就是 Daydream 它的学习成本是怎样的？因为如果我们个人想要去学习开发的话，如果要买硬件或是特别贵，然后更新换代很频繁的话，也会影响大家去学习。所以我想知道这个硬件的设计规格是不是已经基本定下了？如果我们要学习是只需要去关注软件设计这方面。
Okay, so the question was about the space is moving really, really fast, and so as a developer, you want to buy a Daydream device, and you want to develop for it, but you're worried that your device will be outdated at some time, and that could happen quickly. I think the space is moving really quickly. I think you'll see products, come out. I think Google, we have made a commitment to Daydream devices. Like we're working on, making more Daydream devices and bringing this content to a lot of people. So, it is a device that we're planning on supporting for some time. That's why we launched the product.
那这个平台什么时候硬件什么时候能稳定下来呢？就是有没有什么时候我们只专注软件的开发呢？
Oh, the question is when will the platform be stable? I think it's actually quite stable right now. Like I think we have a number of apps that are production apps that are going out and have many users. And I think today is a good day to start developing for it. We've worked really hard over the last year to get this ready, and we put it into a flagship phone for us, which is the Pixel. So I think today is a good day to start developing. Yeah, in the.
Thank you very much. First of all, thank you for your speech. And my question is, what is the difference between Daydream SDK or Qualcomm VR SDK? The advantage of Google Daydream SDK.
Okay. So the question was, I guess, the Google VR SDK versus Qualcomm's VR SDK.
Yes, absolutely.
So I guess the Google SDK is deeply integrated into Android and also includes our controller and special tools to actually use the controller. So the Google VR SDK is integrated as well into Unity and Unreal. And so it's specifically made for Daydream devices.
Do you have any advantages over, video play?
Over video play?
Yes.
So I guess we support DRM video, which is something that a lot of companies want. It's secure video, I guess. But for playing 360 video, I think we're similar in many ways. We support DRM video, and then we also support use of the controller. I think those are, and we're targeting sort of like our Daydream platform, which allows us to have very low latency. Those are great.
Okay, thank you.
Yeah.
就是我想问一下，那个谷歌 VR，我们在开发完这个作品之后，有没有这个上传的这个商店或者途径上传到这个谷歌的应用商店里面去 ，Daydream 应用商店里面去？
I guess the question is about how to build a Daydream app, how to put it on, Play right now. I think for China, we still are working on our strategy. For the Google Play Store elsewhere in the world, it's just the normal process for things on Google Play. So the normal way you would put an app on play is the same for any game. Yeah. Sure. One more. All right, one more episode.
So actually, just following up on the previous question, so can you elaborate more on your China strategy? Like, is there a timeline, and what's the, the thing gonna look like?
Yeah.
If you can share.
So the question is, what is our China strategy? I knew I was going to get this question. I think it's a very fair question to ask. Right now, I do not have any details to share about our China strategy. What I can say is that we do know China is important. We have a history of putting products into China, even in this space with the Tango phone. But that's all I can share right now. I wish I had more for you. All right, one more question. All right. Yeah.
想问一下就是 Daydream 和像第三方那些 HTC Vive 它那关系是什么？就是 Daydream 最后是要同一个平台，是竞争的关系，还是个合作的关系？
So the question is, what is the difference between the HTC Vive and Daydream? How do we think about them relative to each other? So the main difference between the HTC Vive and Daydream is a platform for mobile VR, so it's using phones, whereas the HTC Vive is a platform for desktop VR, so it's using a very powerful computer. The HTC Vive is also 6 degrees of freedom, so it tracks you as you move, and it has controllers that do the same using this external tracking system, whereas Daydream is 3 degrees of freedom for both the controller and the headset. I think for Google, we're excited about the space in general, and that's why you're seeing us build some applications for the HTC Vive as well. We want to make sure that Google products work really well across the ecosystem, and so we're happy to build applications for the Vive. We're also happy to build applications for Daydream, and we think that Daydream has potential to be really broadly adopted, like a platform where a lot of people can get on VR, whereas some of the desktop systems are a little bit more expensive. I think that's all I have time for right now. Thank you guys again so much. I'll be at the booth or here afterwards, and please do check out the Tango Talk as well. So thank you very much.